Okay. What that was.
Do you want it?
No. All right, so we are ready now for, which ones have we done? We're ready for this one? All right, so we're ready for the BFF practice number F. All right, everybody got it? Everybody there? We're in our practice quiz, and it's letter number F, it says at the top. Okay? So here we go. Remember, right now, you can be referring to your cards, but next time we have class, which is what, Monday? We got to do this without. Okay? So here we go. What is that first curve? That's the reciprocal function. So its graph has asymptotes at the origin, or I mean on the x-axis and the y-axis, right? So we are having two asymptotes and a curve that looks like this. Now, when you graph your reciprocal function, make sure that your curves, the things you're drawing, are getting closer to their asymptotes. Don't curl them back in or have them, any kind of U shape or anything like that. They follow those lines. All right, what's the next one?
Absolute value.
Oh, be careful. Yeah, the next one is the greatest integer. And when you graph this one, solid dot on the origin. Start with a solid dot on the origin. And then open it up this way. So just go out a little ways. And then right above that open dot, you have another closed dot. So closed dots go right on top of the open dots. So it looks like that. All those little bars should be the same length. In reality, they are 1 unit long, but of course we don't have a grid on here, so you're just making them all the same length. Okay?
How many curves would you like us to?
Well, I would say you need at least, what, 5? Okay?
5.
What's the next one?
Absolute value.
And what shape is an absolute value?
A V.
A V, that's right. So you just draw your little V, and you are done with that. Now we're going to name them. Now remember, sometimes in past years, kids have not followed the directions. So make sure in this section where it says write the name, you're writing the name. So what is A? 2A. That is your logistic function. And you're going to write the word logistic. Don't abbreviate it. Logistic. You can spell that one. That one's not too bad. What's B? Exponential. And what is C? Be careful.
Cosine.
What is it?
Cosine.
I've heard sine and cosine. Which is it? Cosine. That's the cosine curve. And again, we're not abbreviating it. We're writing the name. Cosine. Everybody good? Now for part 3, we're doing equation. We're doing equation. So what is the equation of 3a? Oh, that's an easy one. That's your identity, right? Y equals x. By the way, these are equations, so they should all be y equals something, okay? What's the second one?
Y equals x squared.
That's your x squared. That's your quadratic, your squaring function. Good. Y equals x squared. And what's that last one?
Y equals log x.
Either log x, or some of you have done like the book did and made it ln x. So either one of those are fine. Either log x or ln x. Both perfectly okay. Okay? Now, this is the hard question. You have 9 already covered. 9 of the functions.
Sine is 3.
So what's missing? Sine. So sine x. Now remember, you can draw it, name it, or write the equation. So whatever you want to do, I'm writing the equation. What's the other, what
Square
other?
root, square root isn't there?
Square root's not there?
We already have square root.
I have squaring, but I don't have square rooting.
And you don't cube it.
And I don't have cubing either. So there they are. You're not going to have your note cards, so you want to be sure that you're very, very familiar with all 12. All right, let's turn it over and do L on the back. We have letter L on the back. Be quicker, this is our last review before we take our quiz next time. All right, so we're sketching these three. All right, so you are sketching x squared. Oh, that's an easy one. What does x squared look
A
like?
parabola.
That's just your parabola, right? So make sure it looks like a curve and not a V. You don't want to put the V in there. Okay, what's the next one look like? That's the exponential. It follows this asymptote in, right? And then it shoots up off into space. And that's the point 0, 1. We should get in the habit of labeling that point because as we pick them up and move them, that's important to know. And now the sign, and no matter how many times I say this, somebody is not going to be careful. Someone's going to be careless with this. And when we do a sign, what point do I start with? Origin. I start with the origin. Actually put a dot on the origin. And then you're going to have a hill on this side, right? And a valley, and it keeps going. And you're going to have a hill and valley over here, and it keeps going. That's what your sign needs to look like. If it's a wavy line, but it's not situated that way, you are not going to get full credit.
So then for the cosine, where does it start again?
The cosine, remember, straddles the axis. Write the name of the indicated function. These are the old ones. All right, so what's the name of the functions in number 2? What have I got there? I have the cubing. I have the logistic. And I have the absolute value. Those are the answers to part 2. Everybody okay? Now we're going to write the equations. So what is the equation for A?
Y equals 1 over x.
Y equals 1 over x. Very good. That's your reciprocal. Remember, for the ones that are equations, we're making sure we have equations. So it's y equals. What's the next one?
Y equals
Square root of x. That's your square root function.
the next one's y equals x.
And the last one is easy. Y equals x. That's your identity. Okay? And now the tough stuff. We need what? We don't have cosine, all right. What else don't we have?
Natural logarithm.
We don't have the logarithmic function. And we don't have the greatest integer, is that right? Okay? All right, well, you see you've got a couple more. You can do those on your own. Certainly, Matt, you might think about doing that because we don't quiz until
Tuesday.
Monday.
Okay.
Because we don't have class tomorrow. We don't have class Friday, Saturday, Sunday. Oh my goodness. Oh my goodness.
Oh, I'm scared.
That's right. Okay. Now, I'm going to return your homework. Oh, this isn't helpful. This is very good.
I wonder how my homework went.
And some other random papers that were returned when people were absent.
Give me it.
This is the lane.
Now.
Friday is service day, and tomorrow is day 7.
When I
Now, you're going to be a little disappointed because you got called on some stuff. But here's my thought on it, people, and I'll be happy to talk with you about your homework question sometime outside of class. But you need to understand that this is worth points, and therefore it requires effort. And copying is not effort. Gobbledygook is not effort. Real effort is like this gal right here, who came in several flexes and asked about, rather than just leaving stuff blank, which some of you did, she actually came in and got help on her homework and completed the assignment. Leaving blanks doesn't count. When you've got 2.5 weeks or 3 weeks to do an assignment, there should be no blanks. I get maybe need help with it, but there shouldn't be stuff just left blank. So as you are preparing your next assignment, which, I changed the date, I sent y'all an email. I changed the date to Monday. So if you, Alright, so again, if you have issues or questions, you can come in and talk to me about it. I'll be happy to talk to you about it. Now we're going to finish up our notes, and then we have one more thing to do after that. I hope we get
Wait, you haven't
everything
put these in the grade book yet?
So those don't go in the grade book.
Oh, they never go in the grade book at all?
Homework replaces the test score.
So, what is this out of?
That's out of 80. That assignment's out of 80.
80.
80. Yes, so that assignment's out of 80. So if you got, if you got minus 39, you're not doing too well, right? No, you need to get better some of this. Okay, get your notes out. No packet.
I'm smarter than you.
Back of page 10.
What's
Here we go.
what's
Back
the
of page 10.
PTS mean?
We are learning about functions, more about functions today.
Mr. Ford, what does EXTPTZ mean?
I'll have to see, I'll have to look at it and see.
Just this? Give me minus 10 on that. That was good.
I got that too. I don't know what it is.
It's that extra practice sheet.
Okay.
Remember?
Yeah, I did it.
Okay, we can talk about it outside of class. Right now, we have learning to do.
Wait, what page?
I guess
We are on the back, we're in our notes. We are on the back of page 10. We're on the back of page 10 in our notes.
That's a cat.
We have been given those functions, and nothing special about those, just random functions. And number 1A says add them. Well, that's easy. What do you get when you add the F function and the G function?
X squared plus X plus 2.
X squared plus X plus 2. That's it. It's that easy. We're adding them. So we add X squared and X plus 2. that is the right order, it's descending order, so that's why I wrote it that way. I'm just adding this and this together. So when B says 2f of x, that's easy, that's 2 of those. So 2x plus 2, or 2x plus 4. See what I'm doing? This is just 2 f's. That's f, so it's 2 of these. So 2 times x plus 2. Now what does this mean? What am I supposed to be doing here? I'm going to subtract them. So I'm going to take whatever g is, which is x squared, and subtract h. So when I distribute the negative, I'll get x squared plus 2x minus 5. Now you don't have to do anything with that because you're not solving it. It's not an equation. You don't have it set equal to 0. All we're doing is subtracting them, collecting like terms.
She's nagging me.
Good. What you doing? I got minus 30. Yeah. There was one page on that where I was like, did you teach me?
Sorry about that. D. What's going on in D? We're going to multiply them. So we take our f function and our g function.
You said and then distribute.
So that would be x cubed plus 2x squared.
Yeah.
Okay, you're thinking to yourself, this must get harder. No, it doesn't. This is it. We're just adding, subtracting, multiplying, and now we're going to divide functions. So f of x over g of x would be x plus 2 over x squared. Now, somebody might make this harder by trying to cancel or something. This is one of those 3-parters, kids. Is anything going to cancel? No. Now, would it ever be possible that something could?
Yes.
Sure, but not in this problem. Now, we're going to go back and look at all the answers that we got. So, this is one of the answers we got. This is one. This is one. This is one. And this is one. And you're going to tell me what the domain of all those is. So what is the domain of this answer that we got right here? What is the domain? All real numbers. Kids, when I say the word domain, 2 things should pop into your head. Radical, denominator. Right? If there's no radical and there's no denominator, then there is no problem, and your domain is all real numbers. So that domain is all real numbers. What's this domain? This one. This one. This one.
X cannot equal 0.
X cannot equal 0. X cannot equal 0 is your domain. Because what is the rule for denominators? They can't equal 0. Denominators cannot equal 0. All right. Now, we're using the same functions, so I'm going to leave those up there. But now, we are doing something different. Okay? Now we're doing something a little bit different. This is called composition, and I know you did it last year. Does anybody remember what we do here?
It was on the SAT.
Izzy?
Don't you put
No, you're not. You're at least trying. That's not embarrassing.
My thought process was to put x plus 2 and then the bracket and then x squared times 2.
Okay, you're kind of on the right track. Let me cover this up, Izzy. You know what would I do there? That is read G of 2. So pretend the brackets aren't there and all you have is this right here. Could you do that? What do we do with G of 2? We put 2 into S, into G,
We will
right?
ask all choir members and members of the liturgy committee that are participating in mass to head down to the
That's in the review, wherever we go. But we're completing our notes today, so make sure you watch the video and get them completed, okay?
Want us to leave our stuff here?
Yes, stuff stays here. And remember when, well, it doesn't matter for you guys, but when the rest of us go, we sit with our town, remember?
Yeah. Okay, wait, I didn't get that, so what?
All right, we're not done yet. So we're gonna find G of 2. What was in front of that? All right, so I'm not worried about the F right now. I'm starting inside the parentheses, and I'm going to put 2 into G. So if I put 2 into my G function, what do I get? 4.
Then becomes
So
F4
G
plugged
of
back in.
2 is 4. Now, this is 4 then. This is 4.
Wait, I don't know why that's 4 though.
You put 2, G of 2, you put 2 in for the X.
Oh.
It's how we do functions, you know that. So, now, this bracket right here, G of 2, is now 4. So now the problem says find F of 4. Well, F of 4 would be 6. So the answer to the problem is 6. When we do composite functions, composition of functions, what that means is whatever number you start with, you plug it into one function, get an answer, then take that answer and plug it into another function. So, what's the next one? Well, actually, the next one is the same thing. It's just a different notation. So this little open circle, it looks like fog, yeah. But that's okay, you know how when you write 32 degrees, you know, a little degree mark? That's what this is, only it's not above. It's written right in line. It's like a little tiny open circle. And it means the same as this. It is a different notation. So if it's written this way, you start with the letter closest to the number. So you put 2 into G. We already did that. 2 into G gave us 4. And then we take the 4 and put it into F. So the answer to this, it's the same problem. So the answer is the same. It's just written differently. It's a different notation. You don't get to question it. It's just a different way to write.
Even for the first one, like, a lot of these. What's the same again?
We put 2 into G and got 4. Then we put 4 into F. 4 plus 2 is 6.
Okay. Oh, it's the F. I got you.
Now, what's happening here? Same letters and numbers, but what's different? Hannah?
You're putting the 2 into the F function.
So we're going to start by putting 2 into F. So 2 goes into F. Well, what do I get if I put 2 into F?
4.
I get 4. Then I take the 4 and put it into G. What do I get when I put 4 into G? 16. So if I do things in a different order, it changes my answer. What was that? That was I. So now we're doing H of F of -1. All right, so what do I start with? I put -1 into F. So -1 into F would give me 1. And then the 1 goes into H, so I would get 3. Remember, when I say we're putting 1 in here, I mean we're putting 1 in for the X value. So we get 3. Oh no, look at the next one. What do you think we'll do here? Put 1 into H. So if I put 1 into H, that gives me 3, right? But now I'm going to take the 3 and put it into G, and I will get 9. And then I'll take the 9 and put it into F and get 11. There's your answer.
This seems so much easier than last year.
Izzy, are you following this?
Yeah, I already got the answer.
You already got it. Okay, you're right on target. Okay, good. Everybody else get 11 there?
So H, you start with H and
Whatever letter's closest to the number, that's what you start with.
then you get that.
You get an answer, put it into the next number, get an answer, or into the next letter. Yep. All right, now L is a little bit different because why? It's an X. Now, don't you dare be confused. Let me remind you that when it was a 2, you put 2 into F, right? So now we're going to put X into G. So we're going to figure out what G of X is. Boys and girls, you don't have to figure that out. It tells you. G of X is X squared, right? But now we have to take our answer and plug it into F. So whatever answer we got, whatever this was, now has to go into F, which means every time we see an X, we're going to put in X squared. So it's going to say X squared plus 2. Here's another one of those. Don't. Just look. Start with what? F of X. Well, this is easy. You don't need to figure that out. F of X is X plus 2. Now that has to go into H though. This is X plus 2. So now we have to go to our H function, and every time we see an X, we have to put in X plus 2. So negative 2, X plus 2, plus 5. That is the H function, but this has to go in place of the X. So that's negative 2x minus 4 plus 5, negative 2x plus 1. And that's it. That's your answer. You don't need to do anything else with that. All right. We'll practice some more in a minute. We have one more section to do here. And then if we have time. Let's finish up our notes here. One more section, problem 4, implicit functions. You probably have never talked about these before, but they're really super simple. To find the implicit functions, you're simply going to get y by itself. Now, here's why it's plural. Find the implicit functions. When I get y by itself, first thing I'll do is subtract x squared. Would you agree with that? Now I need to get y completely by itself, so I need y equals. So what am I going to have to do? Square root. But when I square root, kids, I have to do the plus or minus. So one of my implicit functions is the positive square root, and the other one is the negative square root. And we write those separately, but one will always be the positive root, one will always be the negative root, otherwise they're gonna match, because it's plus or minus the square root. And that's it. That's all there is to it. Those are the implicit functions for problem A.
They don't
What do
reduce.
you mean solve it?
I didn't know if you had told us.
Did you mean take the square root of those? Okay, Gabby, very common error, but let's talk about it. Would you agree, is that a true statement? Right? Okay, so if I did this, and you said 3 plus 4 equals 5, is that a true statement?
No.
No. You can't take the square root of individual pieces, okay? That is not simplifiable. There is nothing to do to it. You cannot square root the individual pieces, unless they're being multiplied. You can if they're being multiplied, but not when they're being added, okay? All right, let's find, so the moral of the story is, you are hardly ever gonna be able to simplify. This is it. Almost always, you're just gonna stop right there. Certainly any problem I give you, you're gonna stop right there. All right, so here we go. We're finding the implicit function. So Toby, how do I start?
You subtract the x, the 2x, and then you square root the y2 and everything else.
So my two implicit functions, always two, will be the positive square root and the negative square root. Done. Those are called the implicit function. And you're thinking to yourself, okay, that's cool, Mrs. Ford, what do you use those for? Well, keep in mind that if you're gonna graph one of these on your calculator, it can't handle y squared. So the only way to graph this equation on your calculator is to split it up into two equations that you can enter into the calculator. All right, try this one on your own. Find the implicit functions for that equation. Okay, find the implicit functions here. This only takes a second. You should have this close to being done. Hopefully you have the square root of 6 minus 3x squared and negative square root 6 minus 3x squared. Is that what you have? Hopefully? You can't do anything. You can't do anything. The calculator won't graph this because it's not a function, but the calculator will graph each of these. So if you put these two together, you'll get what you wanted. All right, same thing here. Be careful. We're solving for y. So just watch your signs on this one. All right, now let's talk about what I did here because I don't want anybody to be confused. All right, so first thing I did was move my x over. Now I was kind of thinking ahead. When I moved my x over, I could put minus x on the end, or I could put minus x at the beginning, right? This is the same thing. I knew I was going to have to divide by a negative, so that made my x positive and my 16 negative. Now, if you have negative 16 plus x, that's fine. Isn't that the same thing? Yeah. Don't be confused about that kind of stuff. That's the same thing. It doesn't matter. So then I divided by 4, and then I took the square root. Now, when I took the square root, what is the square root of 4? 2. So that's why I went ahead and just made the denominators 2, because the only thing in the denominator is a 4, and the square root of 4 is 2.
I just divided them, so it would say y squared equals 1/4 x plus negative 4. Or
So
minus
yours says,
y
what,
equals
the square root of 1/4 x minus 4?
Yeah.
That's okay, that's all right. That's not the best way of writing it, but for our purposes, it's fine.
If that's how we were to write it on a test, would it be right?
What did I just say, is it? Yeah, I'm not gonna tell you it's okay and then mark it wrong. I'm not. Okay, so implicit functions, when the directions say what are the implicit functions, how many answers should you always have? 2. And those 2 answers should look exactly the same, except one will be a positive radical and one will be a negative radical. Otherwise, they should look exactly the same, right? Okay, now we can put our notes away for a week or so.
For a week or so, please.
We're going to start reviewing now, so we don't have any more notes to take over this material.
So we don't have to learn anything new?
No, we're never going to learn anything else, ever. I want to do a quick little recap to make sure we understand this composition thing. So we'll just use these 2 functions. And let's make sure we know how to do just f of 5. And make sure we can do f of g of 3. And then f of g of x. All right, this is just a little quick review. And then I have 5 minutes that I need to spend on one more thing that came out of our meeting this morning that we had. Okay, Brendan? Brendan? All right, f of 5. What's the answer? F of 5? 19. Is there anybody in the room that doesn't understand where that 19 came from? 5 goes in for the x in the f function. So 20 minus 1. Perfect. Now this one.
23.
Okay, I don't know. This is a 2-step problem though. This one has 2 letters, so it's 2 steps. We'll start by doing g of 3. G of 3 would be 6. All right. Then we take the 6 that we got right here and we put it into f. So Patrick said 23. Was he right? Yes. Okay, everybody got that? The 3 went into G. We got 6. The 6 went into F. We got 23. This is the same problem, only instead of a 3, we're just going to use a letter. So what's G of X? Yeah, no confusion. If you're confused by that, you are in deep trouble because it says right here, G of X equals. Now, remember when we got 6? We took the 6 and put it into F, right? We took that 6 and put it right here. Well, this time, I'm going to take this and put it right here. So I'll have 4 times x squared minus 3 minus 1, which I can simplify. 4x squared minus 12 minus 1, or 4x squared minus 13. Okay? All right. Now, because we just talked about this morning, I didn't actually get anything run off, but I'm going to run it off and we'll practice it again on Monday. But we have decided as a pre-calculus group that we are all, give me a BFF, how about, so let's do X cubed. We are all going to quiz or test, and for us it's going to be a quiz, over the basic function vocabulary. So, we've talked about all these words. I don't think they're going to confuse you, but we're going to run through them real quick, and then I will run something off for next time. And then we'll have a little quiz that make sure you can do it. These are the vocabulary words that we have talked about.
Are we gonna get a copy?
I'm going to give you a, I mean, I'll have it written on paper. We just did it this morning, so I haven't had a chance to write it all out and make copies of it yet, but I will. Right now, you don't, I mean, it's great if you want to write this down, but we only have 5 minutes, 3 minutes, so you don't need to write it all down. I'll have it written down for you. But we're going to have a quiz. It's going to look just like this, okay? So I set up the grid so that you could sketch this in, because I think the picture is so beneficial. Okay? First thing, when I look at this word, and this word, I can tell by looking at my picture. This function is increasing on its entire domain, right? So it's increasing, yes, decreasing, no. Continuous, when I draw this, are there any skips or breaks in it? No, so it is continuous. Now, bounded is also pretty obvious. Bounded means there's a ceiling or a floor. There's a top or a bottom to the picture. Does this picture have a top? Does it have a bottom? No. The arrows are kind of clues, right? That it's going forever and ever. So bounded, no. Now what about extrema? What did we say extrema were? Do you remember? I know we only talked about it one time. Extrema were the high points and the low points. So it's like the sine curve has high points and low points, right? Does this guy have any high points or low points? No. This is kind of a boring curve. We'll do a more exciting one next time. How about asymptotes? Does this guy have any? None. And all this I can tell just by looking at the picture. Now, for domain, look at your equation. All reals. Why? Because it doesn't have a radical and it doesn't have a fraction. So its domain is all real numbers. Range. Range is a little trickier, but look at your picture. How high does it go? How low does it go? It goes forever in both directions and there's no breaks in it, right? So its range is also all real numbers. Now, this is the scary one. These are what we call the end behavior markers. The end behavior. Okay? You don't need to worry about writing this. I'll write this for you. You need to worry about what does it mean. What does this mean right here? Just look at that right there. What does that mean? These are two separate problems. That's this way, right? So you are being asked, what happens to my curve as I go to the right? So as I move to the right, what does my curve do? Up. Increasing. Positive infinity. It shoots off into space. Now, what does it do as we move to the left? It goes down to negative infinity. All right, guys, listen. I know that's a little bit overwhelming, and we went through that really fast. We will practice again, I promise. Right now, we are going to leave all of our things, leave everything here, and we're going to head to maths.